In this lesson, some of the enhancements will be at the beginning of the lesson. The teacher asks, if you graph this equation, y equals x plus 2, it will be linear and continuous. The problem with this type of question, it doesn't allow students to make their own connections. It is just telling the students, here's the answer. This equation is linear and continuous. But I suggest that you teach them and let them discover what they notice about the equation. Let them graph it. What do they know? Link their lessons prior to this lesson so that they can fully make sure we fully understand what linear is and what continuous is. And also it'll help address some misconceptions without just directly giving the student the answer, them coming up with the answer. They keep that understanding longer. Another enhancement that I will use in this lesson is towards the middle of the lesson. The students are using pegboards to graph equations or functions, but the teacher does not ask students to look for any patterns as they graph each equation. They just graph them and they just keep graphing them, and then they just record the data on their worksheets. But as you're walking around to your different groups, I will have them start looking at the pattern after each equation that they graph. So sort of having them stop and think, which is an instructional strategy called stop and think, where students then look at that particular equation, determine it's linear or nonlinear. What are some of the features of this type of equation? So if it's linear, what does it look like? It's a straight line. If it's nonlinear, is it a line? Is it a curve? What is happening? And not directly tell students that this is a linear equation. Have them start to come up with that conclusion themselves. So again, also in the middle of the lesson, the teacher will ask, do the pegs appear to form a straight line? And again, that question is so basic that I would prefer to ask students identify what they notice about the line. And then they will start talking about that the line is straight or the line is curved. It's an increasing line, the trend of the line, or those kind of things. And then you can start pulling out what they know. And that increases that cognitive demand for the student. It's not the teacher telling the student, but the student looking at the math and being able to come up with their own connections and see the connections with what they already learned to what they're learning now. The next enhancement in this lesson would be the exit ticket. The exit ticket is a page long for towards the beginning lesson for this. It's not quite the intro of linear versus nonlinear, but it is the intro lesson for looking at non-linear equations. So I would probably change that exit ticket slightly. So like on day one of the exit ticket, I want students to be able to identify those features of linear versus non-linear equations. And then you could also have in there different function tables, different graphs. So the things that they were doing in that first lesson, they are now just being able to identify, being able to look, oh, there's an x squared plus 2. That's a nonlinear equation. So having them sort, which is sort of a basic level, but it's faster and it starts to build students' confidence that they're able to identify the two. And then we can increase the demand of the student. And that way I make sure there are no gaps as I go higher and higher with the cognitive demands of the lesson. So in day two, we're continuing to do looking at linear and nonlinear, and the types of questions are they're harder, and they're having more conversation about these open-ended questions and how to determine a linear and nonlinear equation. and using their information from the day before, those features that they came up with. Then the J's lesson for their exit ticket is that they will still identify linear versus nonlinear equations, but then they can pick an equation, a nonlinear equation, and prove their claim, looking at the function table, looking at the graph that supports that this particular equation is a nonlinear equation. Then continuing the same lesson, the same chunk in the unit, um, on day 3, I would then probably use the exit ticket as written, um, and having students make their own linear or nonlinear equation, or make both at some point, make a linear and a nonlinear equation, um, and use the function table and be able to, and the graph to support their claim.